Good morning, students. Our today's topic in the subject of chemistry is relative atomic mass. So important topic this is. Concentrate yourself. The relative atomic mass is simply a number that is used to compare the masses of different atoms. It has no unit. The mass of an atom can be compared with that of the hydrogen atom or carbon-12 atom. So these are two bases. Any atom can be compared with hydrogen atom or carbon-12 atom. The relative atomic mass of an atom is the number of the times the atom is heavier than a hydrogen atom. So first we are comparing any atom with hydrogen atom. So look now. The relative atomic mass of oxygen is 16. So if it is given that relative atomic mass of oxygen is 16, this means that an atom of the oxygen is 16 times heavier than a hydrogen atom. So this is the meaning of atomic mass of oxygen is 16. Look now, another example. Relative atomic mass of argon is 40. This means that an atom of argon is 40 times heavier than a hydrogen atom. So you have to remember, you have to learn this line. Now using carbon-12 atom, given a mass of exactly 12. So now we are going to compare the mass of an atom with the carbon-12 atom. So look now, relative atomic mass AR. A stand for atomic, R stand for relative. So relative atomic mass will be equal to mass of one atom of an element over 1/12 mass of one atom of carbon-12. So remember, now we are going to compare the mass of one atom of any element with the carbon-12 atom. So look now, relative atomic mass of magnesium is 24. This means that the mass of an atom of the magnesium is 24 times heavier than 1/12 of the mass of the carbon-12 atom. That is, the mass of an atom of magnesium is 2 times, and 2 times will be the answer in a way that this mass will be written in the numerator and the mass of the carbon-12 will be written in the denominator. So cancellation in the same table, 12 2s are 24. So this is the answer 2. So the mass of an atom of magnesium is 2 times heavier than the mass of the carbon-12. So this is a line which you have to learn when you will compare the mass of an atom of any element with carbon-12. So you have to write down, if the question is relative atomic mass of the magnesium is 24, then you have to give this line. This means that the mass of an atom of the magnesium is 24 times heavier than 1/12 of the mass of the carbon-12 atom. That is, the mass of an atom of the magnesium is 2 times heavier than the mass of the carbon-12, and 2 times will be find it out in a way that the mass of the magnesium will be written in the numerator and mass of the carbon-12 will be written in the denominator. After cancellation, you will get the answer 2. So that is actually 2 times. So look now, another example. So you have to learn that line whenever you will write the when you will compare the mass of an atom with the carbon-12. So look now, here is another example. Relative atomic mass of silver is 108. So look at the wording. Wording is same, only magnesium and silver will be replaced with magnesium. All the rest of the line will be same. Look now. This means that the mass of an atom of silver is 108 times heavier than 1/12 of the mass of the carbon-12 atom. That is, this IE stand for that is, the mass of an atom of the silver is 9, and 9 will be find it out in a way that this 108 will be replaced in numerator and the mass of the carbon-12, that is 12, will be placed in denominator. After cancellation, you will get the answer 9. So you will write the mass of an atom of silver is 9 times heavier than that of the carbon 12 atoms. So this is the line which you have to learn. Relative atomic masses are not all whole numbers. So remember, sometimes the answer will come in decimal numbers also. This is because of the existence of the isotopes. Most elements occur as mixtures of the isotopes. Hence, the relative atomic mass of an element is defined as the average mass of the atoms of the various isotopes of the element compared with the 1/12th of an atom of the carbon 12. So look now, the example will clear your concepts. Chlorine has two isotopes, that is 35Cl and 37Cl, in the ratio 3:1. Calculate the relative atomic mass of the chlorine. So the way to solve this kind of question is, so 35Cl. So this 35 will be multiplied with 3 and this 37 will be multiplied by 1. So look now, 35 multiplied by 3, plus sign will be placed here, then 37 multiplied by 1. And this ratio will be summed in the denominator, that is 3 plus 1. So after solving this, you will get an answer. Look here, here is another example of somewhat different form, but the main idea will be the same. Calculate the relative atomic mass of the neon from the following data. Neon has three isotopes, that is neon 20, neon 21, neon 22, and their percentages are given. So look now, this 20 will be multiplied by this number, so 20 into 90 plus 21 into 1 plus 22 into 9, and these percentages will be added in the denominator. Solve it on the calculator, you will get the answer. Look now, here is another question. The relative atomic mass of the beryllium is 9 and that of the relative atomic mass of the titanium is 48. A part, how many times an atom of the beryllium heavier than an atom of the carbon 12? So beryllium is going to be compared with carbon 12. So beryllium's mass will be written in the numerator and carbon 12 will be the mass of the carbon 12 will be written in the denominator. After cancellation, you will get the answer. In B part, how many times is an atom of the titanium heavier than an atom of the carbon 12? So titanium is going to be compared with carbon 12. So titanium's mass, that is 48, will be placed in numerator and carbon 12's mass will be written in the denominator. After cancellation, you will get the answer. C part, how many times is an atom of the titanium heavier than atom of the beryllium? So titanium is going to be compared with beryllium. So titanium's mass, that is 48, will be written in numerator and beryllium's mass, that is 9, will be written in the denominator. After cancellation, you will get the answer. Here is the last question of the lecture. Bromine has two isotopes, that is 79Br and 81Br of equal proportions. Equal proportions stands for 1:1. So when we say 1:1, it means equal proportion. Calculate the relative atomic mass of the bromine. So they are in equal proportion. So 79 will be multiplied by 1 plus 81 will be multiplied by also 1, and that 1:1 ratio will be added in the denominator. After solving it on the calculator, you will get the answer. So students, this was the topic relative atomic mass, one of the important topic in the early chapters of the chemistry. So read this lecture again, learn it, understand it, make your notes. Thank you so much.